Right, so in this session, first of all, we will start by looking at an example of a 5D model. So first of all, let's be clear, why do we call it a 5D? So the reason why it is called 5-dimensional model is that you could preview three dimensions, X, Y, Z. So this model is in 3D visualization, so you can manipulate it. Then we have got time attached to it. So you could see the Gantt chart, which is often referred to as the 4th dimension. And not only the Gantt chart, but also we have got the 5th dimension, which is the cost data attached to this model. So here you could see the labor cost, material, subcontractor, equipment, or so. So bringing all of these dimensions together help us a better preview of the BIM model. Now, first of all, let's be clear as to why do we call it a BIM model. So the key difference between the BIM and traditional CAD environment is that in the CAD environment, we would plot things. So if, for instance, if we have a door to we would have a line and a curve to indicate that is a door. In a BIM environment, we do not draw anything. We basically just drag and drop objects. These are called intelligent objects. They have got the full Excel spreadsheet, full data behind that object. So if I click, for instance, choose any object in my model. So for instance, let's focus on this window here. So here it is providing me with some information which is embedded in this model. So for instance, this is a what type of a so here in this particular software we have got something which we refer to as a recipe, which basically tells us that how this construction component will be constructed. So this is like a recipe for construction. What methods will be used, so we could attach this sort of information, and what is the current status of the task progress. So basically BIM software allow us to attach a lot of data with our intelligent parametric objects. Obviously it is up to the design and production team to ensure that there are right processes in place to add the right and appropriate data. As it is said, rubbish in, rubbish out. So if you have not got good processes in place to include the right data, maybe related to the design or to the production, obviously the model would not have that information. So very often it is said that BIM is just a 10% technology and a 90% sociology. So it is all about bringing people together, having very established protocols and processes so that we are developing an intelligent and integrated database of information, right? So so we learned that call it a BIM model because each object in this model is intelligent. Now, if you want to do something silly with the model, for instance, you want to put a door within a ceiling, the model will not let you do that because every object is intelligent. The door understands what its job is and it goes into a wall, for instance. So here you are primarily dealing with intelligent objects. Now, these objects could be provided to you by manufacturers. So for instance, different manufacturers maybe could provide their object libraries, and these object libraries could be directly embedded into a BIM model. So you have got a very rich resource. Right. So most of the BIM software have got tools that allow you to explore the model. So for instance, this is a pretty old version of a BIM. But here you can see things like an orbiting tool that allows you to orbit your model, so you can have a good preview and a feel of this model, how it would look like before production. You could have a sort of like a walkthrough this model, so just like a walk experience, so you could go into any specific floor. Now, like playing with, as is the case with playing video games, it does require some dexterity and some to effectively use these tools, right? So there are a number of tools, and then there is a camera tool that allows you to take a snapshot of the model, right? So this was the context of model and why do we call it a BIM. Now, what about the fourth dimension? So here we can see that we have got a bar chart. Now, the way this bar chart is different from traditional scheduling software like Microsoft Project is that there is a link between the objects in the model at the top with these task elements here. So when we say backfill basement wall, it is attached to the backfill basement walls component within our model. So so there is an attachment between this bar chart and this model. So we could run a simulation and have a good feel of how our project would be constructed. So we could play a simulation of how our project would come together. There are a number of different ways how these features have been used. Yes, so there has to be some sort of a sort of agreement between the work breakdown structure and the model elements. So your model elements need to map to your work breakdown structure. So in one of the examples which we are going to see, we will see how this mapping between the work breakdown structure and the model objects do take place. So this is very important, and it is this mapping which makes it a 4D model. So we are seeing that these 4D models have been put into use for a number of different purposes. We can use it for as an effective monitoring tool, so we could compare what was designed to what was planned. So here you can see sort of like a traffic color coding scheme is used towards the bottom. For instance, tasks that has been completed would be indicated in a green color. Tasks that had been delayed are indicated in a red color. So you can have a visual interface telling you which of your tasks are going behind schedule. Okay. Also, software allows you to manipulate data in a number of different ways. So for instance, here there's a combo box which allows us to explore the tasks based on our location. So for instance, I want to see how the work is progressing in zone A of the project and then zone B, zone C. So rather than looking into this, we can have a location based analysis. So we can manipulate the data in a number of different ways. So that's the fourth dimension, attaching the time to the model. Now we will talk briefly about the fifth dimension here. So very often the cost data is which is the labor, material, subcontract, equipment, and other, is used to have a good idea about how your project is progressing in terms of time. Now here you could see three different lines or three curves, and I would like you to retain the names of these terms. These are quite important terms when it comes to monitoring and control. So the first graph here is referred to as a budgeted cost of work scheduled. So I think we did in one of our previous sessions learn how to draw a budgeted cost of work schedule. If not, we will go over it once again. So essentially, it tells us that according to the budget, how we should spend our money. So this is, you can see it's a very sort of a typical S sort of a curve where we have got a very slow progress in the beginning of a project when the site activities are being mobilized, and then middle of the project there is a steep elevation, and towards the end we have got a little bit low slope, maybe because of a commissioning and handover works, right? So this is also called a planned value line or budgeted cost of work schedule, which basically tells us how we should spend money during the course of this project. The line at the bottom is called actual cost of work performed. So our site office provides us with data, and so this is a blue line, and it is basically telling us, now this is possibly a very idealistic scenario where what was budgeted and how actually performed is almost overlapping through all. So as it's just a hypothetical example, but very often we would see our actual cost of work performed either below the budgeted cost of work schedule, which would mean that we are underspending on our project, or we are making less progress, or it will be on top of the BCWS line. And if it is on top of the BCWS line, it would mean that your project is being over budget. So here you can see that towards the end, this blue line, so let me close the BCWS line, the blue line becomes dotted. So this is the estimate. So we are reporting progress of the project in the September period, and this is later part is the forecast. So based on the progress made so far, ETC stands for estimated cost to completion. So this will be our estimated cost to completion. So here you can see, because of this cost data, we could have a very clear idea about how much we should have spent at any point of time. So not only we have got a very nice looking visual model at the top, which provides us with all the data about the building and the timeline, but also we have got a full control of the cost information. So it's sort of like a one interface to have multiple dimensions of a project. Now, I don't want to confuse you too much with terms, but these are important terms. The third line here is shown in the yellow. So if I switch other lines, and this is called BCWP, or budgeted cost of work performed. And this line basically tells you that based on the progress you have made on the site, what is the actual earned value. So what is the actual worth of the work that has been accomplished, right? So the previous lines, the BCWS just tells us what you should have spent, and ACWP tells you what you have actually spent, and this is you're telling you basically what is the worth of the work you have actually accomplished. So it basically maps your production with your cost spending, right? And you can also see some other data here. And so if you could have an overview of this table here, you would see at the bottom, there's a cost performance index and schedule performance index. Again, these are two important terms when we talk about project monitoring. The cost performance index tells us how we are performing in terms of cost at any given point of time, and schedule performance index tells us how we are performing in terms of a schedule. So a rule of thumb that we have to remember is that 1 is the baseline, and anything more than 1 is very good news. It basically means that you are either under cost or ahead of schedule, and anything lesser than 1 is slightly alarming. If it is something like 0.96, it's okay, but if it's something like a 0.5, that means you are almost so if it's a 0.5 CPI, that would mean that you're almost 2 times over budget. So alarming news. So, but here in this case, if you look at this figure, the SPI is persistently 1. So we are on track throughout this project, and CPI is running very, very close to 1. So nothing to worry about. And we can also preview this data in an Excel spreadsheet So at different milestone reporting time frames, we are reporting the what we should have spent according to the budget, what we have actually earned based on the production which we have accomplished on the site, what has been the actual cost of work performed, and based on the forecast, what is the estimated cost at completion. So based on the reporting period we are estimating, and this is cost performance index and the schedule performance index here. You can see when we started, it was really in a bad shape, the project, with the cost of CPI of 0.52, but at later stages, we are getting very close to the baseline. Also with the SPI, a very poor start at the beginning, but towards the end of this project, we are getting very close to the 1. So we are delivering in terms of schedule what was planned. So this way we could have a bit more detail than we did review these lines, right? So this is an example of a 5D model, and now in future we will see a great deal of integration taking place between this. Now the it doesn't stop here. We are seeing augmentation of this model with 6D and 7D, with people bringing health and safety data and risk data into the model. So adding different layers of information to an extent that now we have started using an NB modeling. So it could be basically any number of dimensions. So it's very much like you can think of it as a GIS database. So you can have different layers of information on top of your cost, quality, time specifications. Right, so this was the preview of a 5D model. Now we will look into a 4D model within a Navisworks environment. And here we are looking at a hospital construction model. Now, one thing for us to appreciate is that why it is called a BIM model, or how it is different from a traditional model. Now, one thing about BIM is that it is all about collaboration, right? So it's not only about just people talking to each other, it's people's drawings and their data sets talking to each other. Okay, so when we talk about problems within construction projects, often it is not that contractors are not talking to each other. Very often the issues result because of the conflicts and clashes within the design documents, which were not clear. We go on site at the level of a production, we discover that there are a few discrepancies. So the whole idea is that not only people, but people's drawings should communicate with each other. Now we will start by looking at how this model is developed. So here you can see on the left, basically sort of like a folder structure of this document. So it's not just merely a nice visual, but it contains all the drawings and the data sets which comprise this hospital model. So for instance, if I want to just preview what is the scope of furnitures within this model. So I would click on furniture, I could hide the unselected, so I could just focus on it, and here I could see the information about the furniture which is embedded within this model. Or so we could zoom in and zoom out into this model. So if we are having a specific meeting with a specific contractor, we could switch off the layers that we do not want, and this way we could just focus on the aspects which are of interest at any point. So one thing to know is that this model is constructed by bringing the drawings and the data sets from a number of different contractors. Here, for instance, if we want to see the scope of a structural foundations, we could hide the unselected and we could preview the scope of structural foundations or the structural framing work to be completed, or maybe the solar panels which are to be installed in this project, right? So we bring in data from a number of different contractors and put it at one place. So this idea about what is called a big room. So we have got one big model which unifies the data sets from a number of different places. Now, the big question is, how would it happen? It obviously would not happen as a magic. There needs to be right processes in place right from the beginning. So that's why it is often said that BIM is just 10% technology and 90% sociology. So we need to have processes in place as to what are the naming codes that we are using for our different components, how we attach the information, what information we are attaching with each object, what are the coordinates that are being used. So we need to have appropriate processes in place to allow this sort of a collaboration to take place. Right, so once we have this, we can bring in data from other contractors. So there you can see on the top a file format, which is append or a merge. So we could, if we have been provided with a new drawing by another contractor, we could append it using this tool, and we could make that drawing part of this model. Right, so we would see, first of all, some of the features. So the one thing is that this is a tool which is used to support the production tasks. So here you cannot go about and change the floor plans and layouts, because that is not the objective here. The objective is to support the production. If you allow your contractors and subcontractors to mess about with your floor plans and layouts, that will be that will may have a very serious impact on the design. So we have got BIM authoring tools such as Revit or other software vendors like Tekla or Bentley Systems have their own BIM authoring tools. And once we have authored it, then we freeze the design and then we import it into a tool such as Navisworks, or there are similar tools by other vendors such as Tekla or Bentley Systems to support the production element. Now, if we look into the sort of a file formats which are supported, so here if we see the different file formats supported, so on the top you could see the Navisworks NWD file, which is the file format which contains design geometry in a single file. And then there is a NWC, which is a cache file, and NWF, which is a native file format. So this particular file that we are using right now is the NWD format, which contains all the design geometry in a single format. But one thing you would notice is that it's support for a wide variety of different formats. So no matter whichever tool software vendors are using, a lot of different formats and a very most of the popular 3D CAD file formats could be imported. So sometimes we cannot impose across the supply chain that everyone has to use Revit or Rhino, for instance. The different subcontractors could be using a tool of their choice. So again, this is a beauty of a production support tools such as Navisworks to support a wide variety of file formats, so that all the information could be brought into a single file format. Now, if we look at some of the features, so as is the case with most BIM software tools, and there great deal of ways to manipulate the model in different ways. So for instance, there's a home tab, then on the top there is a cube, which basically allows us to turn the model 360 degrees, or there is this sort of a cube here, which allows us to have a predefined view. So for instance, if I want to have a look at how this model will look from the top, I could have a top view, or and at any point, if you want to go back, basically you will have to click the home tab and to return to the home view. And then here we have got a navigation wheel, which again allows us to navigate the model. So here you can see there are features like rewind and zoom and orbiting and pan. There's this hand tool which allows you to pan, or a zoom tool which would allow you to zoom into different sections of the model. Then there is this walkthrough tool that would allow a person to basically have a sort of a walk experience, so we can activate the gravity or deactivate it. So if, for instance, if we deactivate the collision, we can just have a bit of a walkthrough through this model and could preview it. Right, so it's the objective is to give a clear production environment to everyone, so that we are all on the same page. So very good ways for us to manipulate the model so that we could explore it in a number of different ways. Now we would start by looking at some of the features on the home tab in particular. So the first feature is the quick properties. So reminding, we are here talking about a BIM environment. So essentially we are handling intelligent parametric objects. So if I click on any object, for instance, I have chosen a window. So it is indicating it's a glazed window, which is a type. Now I could go into the element view of it, which would provide me with information which is inside this model. So this window which I have selected here is a glazed window. The ID is 9172. So perhaps I could have a bit more information. I could have information on the costing, the material, any commercial information. Then we could have a production information attached to it as to who is the contractor who is responsible for this particular task, or what type of a material it is, right? So it is basically comprising intelligent parametric objects. So all the information which was initially fed within the BIM authoring environment is retained here. There are other features here that we could possibly have a look into. The first one is the clash detection feature, right? So what happens in a traditional construction environment is that in a large project like this, we would possibly have some clashes, possibly different objects maybe occupying the same space in the geometry, and once we go on site, we could discover, for instance, an HVAC pipe is colliding with the pipework which is being laid by a mechanical contractor, and because of this clash, maybe we have some tolerance limits we can't do, so we could send a request for information, and that could delay the task. So the idea behind clash detection is that we need to fix our clashes before things go out on the site. So if we just preview maybe a safe viewpoint. Now, safe viewpoint is essentially a window which allows us to take a snapshot or a perspective of a model from different dimension, right? So here we are given the results of a clash detection between different contractors. So for instance, steel versus plumbing, right? So if we look into this folder, we can see that the clash was run between the steel and the plumbing drawings, and we have come up with number of different cases where there is maybe a physical clash between a steel fixings and the plumbing items which is taking place. Now this will be a case for the contractors or the team to go through each of these clashes one by one to try to identify which are part of the scheme or which needs fixing. So here, for instance, between the steel and the fire ports, the sort of issues that has been highlighted because of this. So the whole idea is to allow us to fix our problems before we go on a production site and discover. So we could have a millimeter level accuracy of different objects, and we could try to identify key clashes here, right? So if we look into the clash detection window, firstly, you can see these two boxes here. So it basically prompts us as to which drawings we want to compare. So here, for instance, we have chosen the structural columns and the structural framing, and we are clashing it against the mechanical ductworks and mechanical equipment pipes. So we could have this as part of a meeting which we are having with the structural and mechanical contractors. Okay, so we could run this clash, and on the top screen you could see the results that have been come. So the software could highlight, maybe for instance in the steel versus mechanical, this software has highlighted 6 different clashes, and then we would go through these clashes one by one. Some of these could be just a common sense, so it could be understandable that there are 2 objects and they have to potential clash, which is part of the design, so we can ignore those, but there could be a few which would require our attention. So things. So the whole idea here is to think before you start the production. So if these sort of issues could be highlighted earlier on, we would not have a need for so many requests for information or change orders emerging during construction work, and as a result of this consequent delays. So at the bottom, you could see there are different types of clashes indicated here. Now, the first one is the hard clash, which is where 2 objects occupy the same geometry or same space in the environment. So there's a physical clash which is taking place between the ductwork. So this could be a hard clash, or there could be a clearance clash where we want to have some sort of a tolerance, maybe for different pipes, and if there's not enough tolerance or clearance, that could be highlighted. Or sometimes there are issues with the BIM model. There could be duplicate objects or so we would like to highlight that. Again, this is a specialist area, and those with a very good knowledge of production would be required to make sense of these clashes and to identify, right? So once we have done our tests, then we could maybe perhaps have a meeting, and here, for instance, we have got different types of tools. For instance, a review tool. We could highlight the key issues. We could use maybe a cloud tool here, and we could add a tag or a comment here. So for instance, we can raise a query that clarify clearance required for this task, and we could set a status as a new, right? So this way we could use it as a sort of like a internal communication tools. We could possibly attach this as an email request to clarify from the subcontractor right? So we could have a bit more zoomed in view within the model, so that we could plan our production processes, right? So this is a bit of a coverage of one of these tools, which is called a Clash Detective. The Timeliner tool is the one which allows us to attach a timeline to our model, right? So now I think this is one of the key focal areas of discussion. So we will go through the timeliner window, but basically a timeliner windows allows us to attach the time data and the cost data with our model, so that we could have a 4D or a 5D environment. Then we have got, so I will come to timeliner in a bit. Afterwards, we have got a quantification window, which allows us to do quantity takeoffs. So we want to have some sort of production related queries. So for instance, how many different door designs we are using within our hospital construction, and who are the manufacturer suppliers. So we could have like a quantity takeoff or material takeoff done rightly from within the environment, right? So as is the case with any software, there is a very useful help feature which is always available. So I want to explore it to learn more about these tools. And then there is a rendering tool which allows us to render our model in a different ways. So we could present it using different material types, material mapping, lighting, environment settings. So for instance, the 4D models are not being used merely to create a timeline, but also to communicate maybe with our communities and with our subcontractors on how the work will progress through different phases of a project. So we could create a nice rendering diagram indicating different phases of the project. Also, we have got an animator window, which allows us to produce animations. So for instance, if we have got cranes, motion and the motion of our vehicles and logistics, we could bring that. And then there is a data tools that allows us to integrate our model with different databases. Now the future vision is that in next 5-10 years we are moving towards what is called Internet of Things, or this concept of a digital twin. So parallel to other physical assets within our environment, we would have a lot of live sensors sending live data about operations of a building or a physical infrastructure, and we could manipulate this data. So for instance, we could have information about how much light or energy we are using, what is our emissions at any particular point of time, things of that sort. So we could integrate external data sources and data tools in the future. So right, so a key focus of this session in particular is the timeliner tool. So if possible, let us go through the timeliner tool once again. So let's switch off this quantification window and let's switch on the timeliner window. Okay, so here you can see a timeline for this project. So you can see the top level tasks and then the summary tasks. So, and this one on the top is the summary task, and then we have got a complete work breakdown structure. So as it's a relatively complex project, you can see it has got quite a few tasks, and then on the right hand side in this column you could see the bar chart or the chart. You could also notice that we have got columns here indicating status of the planned start and the planned end date, We could also use it as a monitoring tool, so we could start inserting the actual start and actual end date, so we could see the discrepancy and the variation between. And then the task type. So within this particular software environment, all the tasks are classified into few categories. So construction is a new construction task. So this would include things which are part of the fabric of the building. We have got a demolition task, which is part of the older structure if it's a refurbishment project. We have got temporary items. This could include things like scaffolding or vehicles, existing site and buildings, and the construction equipment. So we could find different types of tasks. Now this column here is the most important column, which is the attachment column. And this is where we are actually constructing the 4D model. We are mapping the different tasks which we have imported maybe from a scheduling software to different objects within our model. So we will preview later in this presentation how this attachment takes place, and then we have costing data attached to it, so we could see what is the budgeted cost of different work packages, right? So this is the timeliner window, very similar to sort of like a scheduling a software window. Now mind you, this is not a scheduling software, so here the software is not going to give you things such as tools to help you do the critical path analysis or to do resource histograms and resource leveling. This is essentially 4D environment creation. So idea is that you will be using a dedicated scheduling software like a Microsoft project or Primavera or Astra project, and then bringing the finally optimized schedule within this environment, and here you will be attaching it with the model. So you can't do in terms of scheduling too much of it other than inserting the dates. Now there are a number of different ways the tasks can be generated. Now the most common is that we have got a tool here called data sources. So it allows us to bring the project schedule developed in a dedicated software environment such as Microsoft Project or Primavera or a CSV import, so a comma separated file. So most of the scheduling software could export the schedule in this format, and once we have done it, we would import it within this environment. And once we have imported it, then we could do the attachments with the different model objects, which we will discuss a little bit later within that. And then we can configure our model based on how we want to display our start appearance, the end appearance, the early tasks appearance, the late appearance. For instance, we want to indicate the tasks which are on schedule in green and those which are running behind schedule maybe red. So we could configure the display, and once we have done that, then we could play the simulation. So we could do firstly the settings of the simulation. So we could check this settings box. We could indicate the start dates, the plate, and then what is the overlay text which we want to display, right? So for instance, I could see that there is information about the day, week, the tasks, and the total cost, equipment cost. We could maybe add a new line, and maybe we want to have some information displayed in maybe a green color towards the end, and we could indicate what we want. So perhaps maybe for some reasons we want to display the full month name towards the end. So we would display what we want, the information that we want overlaid. All right. So once we have done this settings, then we are good to go and play our simulation. Right. So let's have a slightly zoomed in view of the model. And once we are ready, we could play the simulation, which basically tells us how our project is progressing. So on the left, you could see the project timeline, and on the right, you can see how this project is coming along, right? And so we could use it for multiple different objectives to have a clear idea about the phasing of the project, how this project will come together. So there are a number of different models which have been made available. So far, we talked about a relatively complex building construction, which is a hospital. Also, we have made available a model of a highway scheme, which is one of our local highway schemes. So just for learning objectives, we have got a model here. We could go to the view tab and different windows. Here's a save viewpoint, so we could preview a number of different, for instance, structures within this high-vis construction. So again, this model is created by bringing in the design output. So this is an example of a real life road construction project, which has got multiple different contractors involved. So details about different bridges. Right. So a production environment such as this allows us to address a lot of problems which were inherent and which were an integral part of the traditional construction management, which includes problems in communication, problems in collaboration. So for instance, in one of our local schemes, we had a chance to look into the highway scheme. There were about more than 1,200 RFIs at a chance just at the beginning of the scheme when we looked into, and responding to each of those RFIs could cost more than £1,000 or so. So you could see the costs escalating. So a preview of a good production environment and would help put everyone on the same page. Right. So in terms of what is expected of students to do, we thought it would be useful to have a rather simple model to get a bit more confidence in different aspects of model manipulation, right? So if I go, our key focus is on 4D modeling. So that is one thing which we will like to touch upon. So here from the view tab, we have got a option to choose different types of windows. Now this selection tree is an important window which basically tells us how this model is composed of. So we have got, for instance, and the structural details. So if we want to hide the unselected, we could have an idea about the structural information. And the maybe the other data sets which are part of this. And maybe this, I reckon, is the column details. And okay, so we can see how the designers have produced this model. So these are the key layers. So usually there has to be some sort of a map between those involved in scheduling the software and those who are producing the design document. So there is some sort of a mapping which goes on in the way different layers are produced and different work packages as they are used for scheduling purpose. So this is the standard description. Also, you can see there are different sort of sets, which is a way to cluster different objects within the model, right? So for instance, we could have an idea about external shielding or a concrete footing. Also, so different objects are categorized into different sets. Now, as our key focus is on understanding 4D and how 4D environment is produced, we will open the 4D window. And let's, before that, let's have a clear view of the model. So here is the this model. So let's see the timeliner window here. So as we preview, there is nothing in this timeliner window. It's pretty much empty. So the question is, how do we generate the tasks? So there are a number of different ways. Either we could use an automatic feature. So if I do a right click, there is an option here to add the tasks manually. So I could, for instance, add a task manually, and I could name it maybe something like a foundation. I could give a planned start date, which could be the day today, the planned end date, as we have developed within our schedule. We could use it for monitoring objectives. So in that case, we would provide the actual start and actual end date, and then we could indicate the and the task type. So it's a construction task. So we would, and then we have to do an attachment. So we have to select. So if I just go to here, the selection tree, and let's pin it here, and this timeline liner, right? So I could select the object that I want from selection tree. So for instance, I have selected this object, right? So what I would command is that in terms of attachment, I'll say attach the current selection. So it will, the object that was selected, which is concrete footing, would be attached to this task. So this is one way in which we generate the tasks. And in terms of manipulating the time and date, we could either do it in directly graphical. We could click the mouse button and indicate the dates which are required, right? So this is one way we could directly add the tasks and attach it to different objects within our selection tree. The other method would be the other method is basically we could ask the software to generate the task list automatically, right? So if I just delete this task here, and then I can do a right click, and I will use a command auto add tasks. So automatically add the tasks, and then there are different possibilities for every topmost layer. So what it is going to do is it is going to see how this model is structured, and for every topmost layer, an automatic task list is generated. So it has read that my software has got this model has got no levels, FFL, FRL as the topmost layers, and it has generated the task list automatically. So here you can see the attachment has already been done for you, so we don't have to go through this attachment process. And so we have, and it has given just basically a day for each task, and then we can manipulate the timeline accordingly using this very visual interface. The other possibility is to use maybe the sets feature. So here you could see the key sets within the model. So I would just go back and maybe delete the one, and I could make a command auto add the task for every set. So this is the way different objects have been clustered. This could map with maybe key work packages. So what the software will do, it will read how objects have been clustered into all sets and will generate a task list corresponding to those sets. So here you could see the software has read that the key of the sets within my model include things like site works, piles, pile cap, and it has generated a task list corresponding to those tasks. And then all that is left is for us to do a planned start and the planned end date. Okay. So this is where we have seen how we could generate this attachment process for producing a 4D model. We could the other option is we could import a comma separated file or Microsoft project file, and once we have imported and once we have the task list, then we could map it within with objects within our model. And then we could do a configuration. Let's look into this simulation. So simulation settings. So we would have to indicate firstly the dates of our simulation, which have to map with the details. So for instance, if I see the dates which has been produced by the software. So the software has given the 10th of March 2020 as the start date, right? So once we go to simulation, we have to ensure that we are using the right date. So we will override this date and we will maybe 10th of March. So let's start our simulation at day 4, and maybe let's play it till end of April. Okay, and then we can decide what information do we want displayed on the overlay text. So here, for instance, there is a day and a week information. If there's any other information we want displayed, so we could, for instance, insert a new line and we could display an information on the currently active task, and maybe could display this information in a red color, could insert a new line, and we have got no cost information, so there's no point in displaying that in this example. We could say number of days since the start. So let's put this information in blue and number of days since the start. So we want this information displayed when our simulation is played. And once we have set this thing up, we are all set to go. And I hope it should behave and we start. So this is now simulation playing. On the top window, you can see the information that we have just selected being overlaid. So we could have maybe cost information or any other tracking information. So it will basically go through different phases. So we could break our work into different phases. We could maybe have our site planning and logistics done accordingly. Okay, so this way we learn the timeliner window. We could explore a few other features. So there is this saved viewpoints. So this is essentially a window which allows us to take different perspectives. So for instance, we have got a fly through. Let's run through the a fly through animation. So here we click on the animation and have a fly through or a house construction project. And if we want to maybe have a look at the model from a specific location, so for instance, that's the perspective, maybe we want to have a closer view of the this window from this elevation, we could save this viewpoint. So it is very much like taking a photograph of your model from a specific location. And then we could export the animation. We could also bring in the temporary construction elements such as scaffolding or planning for site logistics, and create those sort of animations as discussed before.